This is lesson 11.3, Solve Radical Equations. You should be on page 729. An equation that contains a radical expression with a variable in the radicand is a radical equation. You can see an example of a radical equation here. Can you see the variable inside the radicand? To solve a radical equation, you need to isolate the radical on one side and then square both sides of the equation. When you squaring both sides of an equation is a legal step, is what this key concept is telling you. If two expressions are equal, then their squares are equal. Okay? So what that's telling me is, let me make up something simple. If I did 2 plus 1 equals 3, I think you would all agree that that's true. If I square both of these, this side gives me 9, this side would give me 2 plus 1 times 2 plus 1, and isn't that 3 times 3, which would equal 9? So I can square both sides of an equation, and it should maintain the equal in the equation. Let's solve a radical equation now. So from the previous notes you took, you need to isolate the radicals. So you got to treat the radical like the center of the onion. So you can see I put the center layer here, and those are the other layers of the onion. I have to get rid of minus 8 first. So I'm going to add 8 to each side, which will cancel out the minus 8 on the left, and 0 plus 8 on the right is 8. And then my next layer, I got to get rid of the times 2. So you notice I'm dividing each side by 2, which gives me radical x equals 4. And then I can square each side of the problem, which you see they're doing here in the book. The square cancels the square root out, which gives me x on the left, and 4 squared is 16 on the right. The solution is 16. And then I can check that. If I just go ahead and plug 16 in the beginning of the problem, this should work out to 0. Why don't you pause the video and try these two? Okay, we're back. So for this question here, I wrote my work here. We would have to add 7 to each side real quick, which gives me square root of x equals 7. I would then need to square each side to get rid of the square root, and x would equal 49. And in that second question, I would have to peel away the onion, add 3 to each side, divide by 12, which gives me square root of x equals 1/4. Now I square each side. That's going to get rid of the square root, and x would equal, well, 1/16. Okay? Let's solve another radical equation. Here for this, you can see I already drew my onion up. The center of the onion is the radical. So step 1, I got to get rid of the 12. So I'll take away 12 from each side, which gives me 4 times radical x minus 7 equals 16. Then I'll divide each side by 4, which gives me radical x minus 7 equals 4. Now I got to get rid of the radical. So I'm going to square each side, and when I square each side, you'll notice that square eliminates square root. So now I have x minus 7 equals 16, and then I can add 7 to each side, and x would be 23. So the solution is 23. And then I would disregard this to check it. Just take 23 and plug it in for x and see if it makes the statement true. Now, if you have radicals on both sides of the problem, or if you have more than one radical in the problem, it's important, if you have more than one radical, to be sure that each side of the equation has only one radical before starting to square. Okay, so when I look here, I'm like, oh, I got more than one radical in the problem. Make sure that you only have one radical on each side of the problem before you try to square. Okay? So for example, when you look at this guided practice problem that I'll have you try, I have 2 radicals in the problem, but they're both on the same side of the equal sign. my first step here would be to add radical x to each side. So now I'd have one radical on each side of the problem. Now I could square and go from there, okay? So this problem, I do have radicals on each side. So my next step, square each side of the problem, which the square eliminates the square root. Now when you get to here and the square roots are gone, this is review of Chapter 3. I don't have all my variables on one side. I got to get all my variables on one side. So take away x from each side. So the x's on the right cancel. I have 21 on the right, and now I have 3x minus 1x is 2x minus the 17. And now it should be a couple quick steps and you're done. Add 17, which gives you 2x equals 38. Divide by 2, and x is 19. And then you can check it. If you plug 19 in for x on each side, when you work this out, it ought to give you the same responses as if you work that out. Why don't you pause the video now and try these three based on what we just talked about here. Okay, I'm back. So for number 2, first of all, we have to isolate the radical. So we got to peel away the onion. Take away 7 first, which gives you radical x minus 5 equals 5. Then you can square each side, as you can see I'm doing here, which gives you x minus 5 equals 25 now. And then add 5, x is 30, and you can check that to verify that this works out to 12. Now for number 3, I have 2 radicals in the problem. They're on each side of the equal sign, so everything's good. Square each side. The square gets rid of the square roots, which gives me x plus 4 equals 2x minus 1. Okay, this is review of Chapter 3. I can't have x's on each side, so I took away x from each side to give me 4 on the left and x minus 1 on the right. And then I added 1, x equals 5. And I can check it real quick. If I check it just to show you, 5 plus 4 is 9, and the square root of 9 is 3 over here. And then over here, 2 times 5 is 10, minus 1 is 9, and the square root of 9 is 3. So in both cases, I'm getting 3 equaling 3. So this is a true statement. This is an answer. Here, I had to add the radical x to each side to get radicals on each side first. And then you can see I squared each side to get rid of the radicals. So 4x minus 3 equals x. I took away x from each side, so 3x minus 3 is 0. I then added 3, and then divided by 3, and I'm getting x is 1. Okay? Now, extraneous solutions. When you square both sides of an equation, you can get results that are not solutions of the original equation. Okay, so in other words, you could be doing your work right, but when you square both sides of an equation, the result might not be a solution. Okay, when that happens, it's called an extraneous solution. So whenever you square both sides of an equation, you should check each solution to make sure there are no extraneous solutions. So if you didn't check and wrote down an answer, and that answer doesn't end up working, I'd have to mark it wrong. You've given me an answer that's not right. So when you do square both sides of a problem, it's important to quickly check your answer. Let's look at an example of a problem that has an extraneous solution. Like, let's solve this. The square root of 6 minus x equals x. Now, I have a radical in the problem, so step 1, I'm going to square each side of the problem, and you can see that here. I squared each side. Next step. Oh, do you notice? This is a second-degree equation. So this is a good review of chapters 9 and 10. I'm not going to factor it. Am I going to use the quadratic formula? You know, can I use my graph and table method? Could I complete a square? Well, this looks kind of easy, so I'm going to move everything on one side, 0 on the other. So I'll add x to each side, and I'll take away the 6, and I get to here, and then I notice, wow, that's kind of an easy factoring problem. Positive 3 times negative 2 gives me negative 6. Positive 3 plus negative 2 gives me 1. So there's my factoring. X minus 2, x plus 3. and I get two solutions. I can plug in 2, and I could make this work out to 0, or I could plug in negative 3. Let's check each one now. If I plug a 2 up here, I get 6 minus 2 is 4, and the square root of 4 does equal 2. So that checks out. But let's plug in negative 3. If I plug in negative 3, I get 6 minus negative 3, which is 9. So I get the square root of 9 over here, and I have negative 3 on the other side. The square root of 9 is 3, not negative 3. So this is not a solution. This would be an example of an extraneous solution. Negative 3, even though the work gave me negative 3, it doesn't actually work in the problem. Okay? So that would be an example of an extraneous solution. Solving a real-world question. You can use the techniques we've learned to solve a real-world problem. Like, I'm not going to read through this whole thing out to shorten up the video, but they ask you, find the length, which is L, find L, to the nearest foot of a sailboat's water line if it has a hull speed of 8 nautical miles per hour. Well, S is the speed. So you notice they plugged 8 in for S. I got to get the radical L by itself, so they divided each side by 1.34, which gives you radical L equals 8 divided by 1.34. Then they square each side of the problem, and the square eliminates the square root, and so they simplify it. The water line of the boat is about 36 feet. They said round to the nearest foot. So this is about 36 feet. So using the techniques we learned in this video, we can solve a real-life problem. Okay? What I would like you to do real quick is pause the video and try number 5. Okay, I'm back. So let's solve this. So first step, I see a radical in the problem. It's isolated on one side of the problem, so square both sides. That gets me 3x, so you can see these better. That gets me 3x plus 4 equals x squared. Oh, I have a quadratic. Well, I'm going to put everything on one side, 0 on the other, and I'll go from there. I'll decide if I want to factor or use the quadratic formula or whatever. So I'll take away 3x and 4 from each side, and I get this. And now I'm like, wow, that's not very hard to factor. Negative 4 times positive 1 is negative 4. Negative 4 plus 1 is negative 3. That's an easy factoring problem. Negative 4 and 1 is my factors. So if I plug in 4 here and negative 1 here, I'll get 0. Let's check. Do I have any extraneous solutions? If I plug in 4 here, 3 times 4 is 12, and 12 plus 4 is 16. So I'm checking, is the square root of 16 going to equal, that would be a 4. Is that true? Yeah, that is true. So 4 is an answer. Let's check on negative 1. If I plug in negative 1, I have 3 times negative 1, which is negative 3, and negative 3 plus 4 is 1. And on the other side, I have negative 1. Is the square root of 1 negative 1? And no, the square root of 1 is 1. So this is an extraneous solution. My answer to the problem is only 4. Okay? I'm going to pause the video here. If you have questions, make sure you ask in class.